This is Year 14, A22 Physics 5. And these questions are answers to the deflection of charged particles past paper questions that you got from 2004 to 2009. The first question is A22 Physics 5, May 04, and it's question 3A. Just scan in a little bit. A particle of charge minus q enters a uniform field of flux density B at a point P as shown in figure 3.1. So there's point P. The particle has a velocity v at right angles to the field. Write down an expression for the magnitude of the electromagnetic force on the particle at point P. And of course F is equal to B times Q, which is the charge, times V, the velocity at which it's moving. Describe exactly the direction of the force in part 1. So you have to use your left hand rule, which is, if I just scan out a wee bit, there's your left hand rule there. FBI, the field is going from here to here, so that's the direction of this finger. I is the direction that a positive particle will move, and therefore, since this is a negative particle, then if a negative particle is moving this way, a positive particle will move the opposite direction. And therefore your hand is going to go up like that there. And so there's B and there's I, and therefore the force is perpendicularly out of the page. And you need to say both those things, that it is perpendicularly and then the second mark is out of the page. And that's what gets you your 2 marks there. Part B, figure 3.2 shows 2 horizontal plates between which a uniform vertical electric field is applied. The magnitude of the field is adjusted so that a charged particle of finite but unknown mass and known charge moves horizontally between the plates. The particle is negatively charged. On the circles on figure 3.2 indicate the polarity of each plate. So you know that you have a particle. Now every particle has got a mass and therefore a weight and will be pulled down by acceleration due to gravity. So if you have a particle moving through there, it should be pulled down by acceleration due to gravity, and therefore there must be an upward force due to the plates, which is keeping that moving in a straight line like that. Therefore, if you have got a negative particle which is moving through there, it must be being repelled from the bottom plate but attracted to the top plate in order that it doesn't follow the path of a parabola but is actually repelled up towards the top plate. So that was part 1 of that question. The next part of the question tells you, part 2, that the particle is negatively charged. The potential difference between the plates is 200 volts and their separation is 5 millimeters. Calculate the magnitude of the electric field intensity between the plates. So that's just your equation. E is equal to V over D. You must watch out for millimeters to meters. So it's 200 over 5 by 10 to the minus 3. And that comes out as 4.0 by 10 to the 4, or 4 by 10 to the 4. And that's in volts per centimetre. Volts per metre, I mean. We had to change that into metres. The magnitude of the charge is 3.6 by 10 to the minus 17 coulombs. Calculate the mass of the particle. Now, we have got 2 forces acting on the particle. We've got its weight, which is equal to mg, and we've got the force due to the fact it's moving in the electric field. So we know E is F over Q, so therefore F is equal to E times Q. And so what we're going to do is equate those 2 forces. So mg is equal to E over Q. And therefore if we want a value for m, we have to divide E times Q divided by G. And so when we put those numbers in, it's 4 by 10 to the 4 times 1.6 by 10 to the minus 19. And that's all divided by 9.81. And the answer comes out to 3 significant figures, 1.47 by 10 to the minus 13 kilograms. And that's your answer.